Look at these bar graphs. Now, notice the x-axis category. That's a country. These are all countries. Okay, then the y-axis was unemployment rate in 2008. Okay, now look at its bar graph on its side, but still, instead of, everything's been flipped here, still these are categories, different degrees versus income. Some high school graduates, some college, all the way up to a doctorate. You got a professional degree versus a doctorate degree. You can look up what the differences there. The differences between a professional and a master's degree. Anyway, there you go. This was from 2005, so this is a little dated here. 2 bar graphs. Then we have another bar graph. Cancer rate low for Native Americans. Again, these are categories, okay? White, non-Hispanic, Hispanic, Black, Asian Pacific Islander, American Indian, Alaska Native. Men, darker there, women in the lighter shade. All right. You can see anyway, these are categories. Then the big difference, okay? Big difference now with a histogram is these are in intervals, these aren't categories. So you have age is the one variable. We're looking at age here, and we're putting these folks in an interval of those that are age 16 to 24, those that are 25 to 24. Anyway, you have an interval here, so that is the difference. What is this? Percentage of men spending at least 1 hour per week participating in sports or exercise. As you can see, it goes down. All right. Notice, though, here's another big one. We have heights, distribution of heights. Notice that this is very, very close to special type of curve. You'll see that later. Anyway, so it doesn't really look like an interval, but these are all height. In fact, when you're talking here, it's probably in the 5/6s. So 66 to 66.9 inches, 67 to 67.9 inches, and so forth. Then we have a histogram of age at death of Australian males in 2012. All right, so this looks to be, here you have 20 to 40, so anyone between 20 and 40, between 40 and 60, 60 and 80, 100 to 80, and so forth. Look at those time intervals at the bottom. Histogram. All right, continuing this. Let's talk about symmetry. Notice the male heights, or the heights on the previous page. I believe they're male. Symmetric, a bell shape. Okay, then you can be skewed to the left or skewed to the right. Now let's talk about that. Notice how the tail is to the left. It has a long tail to the left. That's why it's skewed to the left. It has some outliers there to the left. Then something could be skewed to the right. It's got some outliers to the right. It's all about the tail. Okay, so a histogram is skewed to the right if the longer tail is on the right side of the mode, the most frequent one. All right, a histogram is skewed left if the longer tail is on the left. Skewed left, skewed right, skewed left. There's a lot of different graphs have skewing. All right, so what is this one? Holy cow. Notice that, but it even has a tail here. This would definitely be skewed to the right. One about this one. This one is almost looking roughly symmetrical, but it's got some things going on there, so it would be skewed to the left. Like it's really, really close to being roughly symmetrical. All right, but it is skewed to the left. So this would be the middle. These two kind of cancel each other out. That one kind of cancel each other. That one, and then you got that. So skewed to the left. Skewed to the left is also called a negative, being negatively skewed. Okay. When that happens, here's the mode. The median would be dragged to the left, and the mean would as well. It would be, so let's say, if 5 students in the class got 100, and then, or let's say 20 kids in a class had an average of 90. They did really well. And then you had 8 students that all got below a 40. Bad. it'd be taken, the data would be taken that direction. And then you have perfect symmetry. This is a normal curve. We'll discuss that later, where the mean, median, and the mode are all in the middle. Then you have something that is positively skewed to the right. Here's what could happen. You could be in a neighborhood where 15 homes are worth $100,000. And then there are 3 homes that are each worth $2 million. Well, the mode is 100,000, but everything is going to be dragged this way. All right. Well, let's say the average was about 100,000 for the 15, because if not, you'd have an issue with that right there. Anyway, you get the point. If you have 3 outliers, you have 15 homes, and the average of those homes are very close. They're all between 90 and 110,000, and they average. They have a mean of 100, but the mean is, I'm sorry, you have 3 to 5 outliers, $2 million homes and whatnot. That's going to make the neighborhood look like it's more expensive when it's not, though. You just have those outliers. All right. Then lastly, let's talk here, because on day 1 we're going to start making this stuff. A stem plot, stem and leaf plot. These are pretty easy to make. So this stands for, this would be like the tens digit, and this would be the units digit. Okay, so 12, you would put a 1 there, and then you don't have to write stem and leaf. You would do, I just have them like that on my paper. You would put, a 1 and a 2. That's 12. You do go in order, so you don't need a comma either. That's for 14, and then you have one that is 18. Then you have 2 23s. Yes, you have to write them both. That shows me that there are 2 23s. This is for the 25, 3 for 32, and 35. It needs to go in order. If you have 2 23s, you write out 3 twice. So math scores, what I know is the high score is 94, and I know the low score is 50. And what I could actually do, I could find the median, because boom, 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 boom. You get the point. You gotta say boom, though, if you're doing this question. There. What do we got? So the median would be the average of those 2, which, can you see this? 84. You could use that to find the middle score. All right. Then look at this side-by-side stem plot. Okay, so pulse before and after exercise. Someone had a pulse of 68 before, they might be the one with 146 after, and so forth. Notice it's sharing there. And if you get one that's 104, you put a 10 tens, and then 4, and so forth. All right. Here are the home run leaders for the National League and the American League. Now, this was before Mark McGwire, Sammy Sosa, Barry Bonds, and so forth. So 61, Roger Maris, Babe Ruth. So then you can kind of see who had the better average, what the median is for each league, and so forth. All right, stem plots. We will make a stem plot together when I see you. Then a time series plot. Gold prices. Okay, so the order does matter, because this right here is 1999, and this here corresponds to 1983. So it goes up and down. You connect the dots. They look pretty cool. I actually used this 3 years ago in my master's project here. Complete game percentage, years from 1960. 1960s for baseball, a lot of complete games. And then 2016, 2015, hardly any complete games. All right, time series. This is another time series plot. Notice you're not connecting the dots. R did this for me. We're going to use R this year. And I believe this is, the Dow Jones Industrial Average. I can't read the bottom. I think that says 2010. No way. That we'd have to have a crash somewhere in there. Anyway, might not say 2010. You get the good point. Things going up. What happened there, do you believe? Okay, anyway, Dow Jones Industrial Average, the stock market. And folks, that is it for this week 1 packet. We will start, when I see you that day 1, we will be learning. We are going to start with the other packet. We're going to start crunching some numbers. All right. Our goal, no matter how our schedule is, our goal is to take our first quiz the third Friday of school. Whether it's probably going to be over a Google Meet. I will tell you how we'll be proctoring those on day one. This is Yak Math Videos signing out.